Hello everyone. We have a question of inequality, a modulus inequality, and definitely we have to find the solution. We have two different methods to find the solution of this particular modulus inequality. The first method is an algebraic method and the second is a graphical method. We would be discussing both the methods so that you could get a very clear-cut idea how to work on it and how to observe and get the final answer. Because we have an inequality, so definitely your final answer would be the set of values, not a particular value. And after working how to get the set of values, so we will be discussing on both of them. Let us start with the algebraic method. The process is very simple. For algebraic method, just go on squaring both sides, and instead of this modulus sign, just use the round bracket and then square both the side. Use a minus b whole square and a plus b whole square and simply use the formula for a minus b whole square, which is a square minus 2ab plus b square, and 3 square is 9, and a plus b whole square would be a square plus 2ab plus b square. Multiply by 9, and after multiplying by 9 rearrange them, add the like terms, and after adding the like terms then simplify them and convert it into a proper standard quadratic form like we have done. After rearranging them, adding the like terms, that means x square with x square, x with x, a constant with constant, and finally we have this. As you can see over here, what I have done over here, we had a quadratic equation with negative value, negative coefficients of x square. We can also take this one and work out, it is not wrong, but if you wanted to avoid the negative coefficient, just take -1 as common, and after taking -1 as common, definitely the sign of all of them would change. This was negative, negative, negative. If you take negative as common, definitely all of them would become positive, and that -1 that you took when divided on both sides, 0 divided by -1 would be 0. But keep in mind, whenever you multiply or divide a negative value working with inequalities, make sure the direction of the inequality would change. That means if I take -1 as common and then divide on the other side, definitely the direction of the inequality would change. Or if I just look at it in another way, just do one thing, just move all of them on the other side of the inequality. When I move all of them on the other side of the inequality over here, this -5x over here would become positive, -22 would become positive, -8 over here would become positive. So everything would be here, and that would be greater than, and nothing over here, it would be 0, and that is what I have written over here. So it is totally up to you how to understand and work on it. So the next step is that find the critical values, and when I say the critical values, means the values that would definitely decide the set of values for the given inequality. And for finding the critical values, definitely we have to use a quadratic formula, and by using the quadratic formula, the values that we would get would be the values that are actually the values of x on the x-axis, because this inequality is like greater than or less than whatever it is 0. That means this y is 0. So when we say the critical points, or when we say if y is 0, what are the values of x, we use the quadratic formula and get the two values, which are also called as the x-intercept. So just use the values of a, b, c, which are a is 5, b 22, c 8. Use the quadratic formula, simplify them, get the two values of x, which are -2 upon 5 and -4. They are also called critical values. In other words, you can also say they are the x-intercept. And -2 upon 5 is definitely greater than -4. So -2 upon 5 over here and this -4 over here. The coefficient of x square was positive. Positive 5 means the graph would be a U-shaped, and when the graph is a U-shaped, so definitely when we could easily work out based on this particular inequality, which is saying that this particular quadratic equation is greater than 0, and when we say it is greater than 0, so definitely it would be positive, and if it is positive, that means a positive value of y. So by observing the graph, we could easily say that if we need a positive value of y, we need those values of x which are greater than minus 2 upon 5. If you take any value greater than minus 2 upon 5, if you observe the graph, you can see, yes, it would give a positive value of y. Or in other word, if you take any value of x less than negative 4, will definitely give you a positive value of y. So finally we can say that by looking at the graph, the set of values of x which satisfy the given modulus inequality are the values of x greater than minus 2 upon 5, as I have written over here, x greater than minus 2 upon 5 and less than negative 4. The question that we are working on contains modulus on both sides. We would come across some question where we would have a modulus on just one side of the inequality, not on the other side. In those questions, the process would be almost 100%, I would say 90% same, but at the end, there would be a slight change in the observation. So when we will come across those questions, so at that time, I would be comparing those questions with this one where we have a modulus on both sides and a modulus on one side of the inequality sign. So you should know that if you have a modulus on both sides, then what to do, and if you just have a modulus on one side of the inequality, then what to do and how to write the set of values of x. So finally from here it is observed that if you have a modulus on both sides, simply follow the process based on the graph, write the given set of values, and you are done. As I said in the beginning, we have a graphical method also, so let us work on the graphical method and see how the graphical method works. On both sides of the inequality, we can see we have modulus linear equations. So linear equations definitely equal to y, and based on that, just make them equal to y and use sum of the values of x. I have taken too much. It is not necessary to have so much values. You can use like 4 to 5 points, 4 to 5 values of x, and then work out from the given modulus equation the values of y, because both the linear equation have a modulus, and we know that the modulus is never negative, and when we say the modulus is never negative, so definitely a modulus can have a minimum value of 0 or just a positive value. It will never have a negative value, and because both sides contain modulus, so definitely if we observe all the values of y, they are completely positive for both the given linear modulus equation. Just draw the graph of both the modulus linear equation, and linear means a straight line graph, and you can see that the graph that we have made is basically a straight line graph. As we said that the modulus is never negative, and you can see from the graph also that the graph is just touching the x-axis and bouncing back. It is not going below the x-axis, because if the graph goes below the x-axis, definitely below the x-axis y is negative, and modulus is never negative, that means y is never negative. That is why both the graph are just touching the x-axis and then bouncing back, because on the x-axis y is 0, and I said that time that the value of a modulus can have a minimum value of 0. As you can observe and see the graph that both the linear graphs are intersecting at 2 points, and the 2 points are basically the same 2 points that we got over here, which is minus 2 upon 5 and negative 4. So this one is negative 4 and this is negative 2 upon 5. Now comes to observe the given two linear modulus equation, I have used two different colors to represent the graph for both the given two linear modulus equations. The first one, which is the 2x minus 1 with the modulus sign, is represented by green, and the second equation, which is 3 multiplied by x plus 1, is represented by x. If we just observe the graph, that these are the two intersection point, and if we take any value greater than minus 2 upon 5, it is observed that the red line is above the green line. And when we say the red line is above the green line, that means this 3 modulus x plus 1 is greater than 3x minus 1. Why? Because the red line is above the green line, so this one is greater than this one. If we take any value less than negative 4, again it is observed that the red line is above the green line. That means the red one is greater than green one, and the red one is represented by 3 and x plus 1, and it is greater than green, and green is represented by this. So if we just look at the given question, we can see that over here it is saying that we need those set of values of x where this 3 modulus x plus 1 is greater than this one, and this is represented by the red line. So red is greater than the green one because this is represented by green. So red is greater than this green one. That means where the red is above green, that is the set of values where the red is above the green. So over here the red is above the green. That means all the values less than minus 4 are the set of values. Over here again the red is above the green, so all the values greater than minus 2 upon 5 are the set of values for the given equations. So it is totally up to you whether you wanted to go for graphical method or the algebraic method. Both are acceptable, but I would recommend that go for algebraic method. That doesn't mean that this method is wrong. No, it is totally up to you. You can use any method. Both are acceptable, both are correct.